The four mighty forces. Why does Earth continue to circle the sun? How does light move? What binds nuclei and atoms together? The goal of scientific description of the forces governing interactions at both big and microscopic sizes, from planets to particles, has been pursued for decades. They are aware that the universe we live in is shaped by four fundamental forces: gravity, electromagnetic, the strong and weak nuclear forces, and electricity. Force of gravitation. A force that is most familiar is gravity. It maintains Earth in its orbit around the sun and keeps us rooted to the ground. The general theory of relativity describes gravity as bending and curving spacetime, which has an impact on the motions of planets, stars, galaxies, and even light. When something has mass, it distorts spacetime and attracts other objects. Two items are attracted to each other by gravity. Its strength diminishes with the cube of the distance between the two objects, although it roughly increases with their masses. This implies that the gravitational pull between Earth and the Moon would be stronger if the Moon were twice as far away as it is now. The force of electromagnetics. Electromagnetism powers our television sets. This force is carried by light, which keeps electrons in orbit around atomic nuclei, lights up our homes at night, and permits the formation of chemical compounds. Electromagnetism is the force that combines magnetism and electricity, as the name suggests. A moving electric field generates a magnetic field, and vice versa, demonstrating their interdependence. Electromagnetism operates at an infinite range and, like gravity, loses strength with the square of the distance between two things. But only charged items may use electromagnetic, and each object's charge determines whether it attracts or repels. One charge of each type attracts, but two charges of either kind repel one another. Even though electromagnetism is more powerful than gravity, it is frequently equalized by the equal amounts of positive and negative charges that create neutral atoms in big objects. For instance, although Earth is electrically neutral, the magnetic field it possesses comes from electric currents flowing through its liquid core. Powerful nuclear force. While they operate at smaller distances than atoms, nuclear forces have an impact on our daily lives. The atomic building blocks are held together by the strong nuclear force, or strong force for short. It consistently draws in and functions on two distinct atomic sizes. The protons and neutrons that make up the building blocks of all elements are held together at the level of an atomic nucleus by the strong force. Even smaller, the oppositely charged quarks that make up protons and neutrons themselves are held together by the strong force. The strong force is the strongest of the fundamental forces, as its name suggests. It is around 100 trillion times more powerful than gravity and 100 times stronger than electromagnetic. However, the strong force is only effective over very short distances. Anything larger than the nucleus of a medium-sized atom, about 100 million times smaller than the width of a human hair, quickly loses influence and other forces gain strength. Weak nuclear force. The weak force governs interactions between subatomic particles, which are the tiny particles that serve as the foundation for matter and include protons, neutrons, and electrons. In particular, the weak force has the ability to transform one type of quark into another. Protons and neutrons are composed of two quark varieties, up and down. The weak force can convert a neutron's down quark into an up quark, transforming it into a proton and changing its electric charge from neutral to positive. If that neutron was in an atom's nucleus, the transition to a proton would transform it into a different element. These reactions occur all the time in our sun, giving it the energy to shine. This type of action is also seen in radioactive decay, in which atoms spontaneously release energy and subatomic particles. The weak force operates at the smallest distance scales, 1,000 times smaller than the strong force. It is about 1,000,000 times weaker than the strong force, but it is still much stronger than gravity.